Hey guys, here's a video to help you with those kind of oddball questions where they ask you to use differentiation or integration. So I'll do 13, I think it's 13a, where they're basically telling you to find a series to represent this function. All right, now we know this one. This is our bread and butter right here, right? This is our geometric series that we know for sure. Oops, cut that off, there we go. And in fact, on Friday, we manipulated this one. It kind of looked a little bit like this. Oops, sorry, one sec. Kind of looked a little bit like this. The problem is this is squared, and we didn't have that. We were able to do some kind of little finagling like this to make the 1 plus x, and we were able to figure out that really all we had to do was switch out our x to negative x, and it worked out just fine. So I need to end up with something like this, and the whole trick here is it's one of those things where you see it once or twice, you just start to remember that, you know, this is really a variation of the derivative of that. So if I can take the derivative of this one, I'll get something kind of like that one. And that's sort of the main idea here. And if I can differentiate the function, I can differentiate the series, since those are supposed to be equivalent anyway. So if I rewrite this, I'll do this one time here. I'll do 1 plus x, I'll take the derivative. This is really 1 plus x to the negative 1, so negative 1 plus x to the negative 2. No need for a chain rule kicker. And I've got negative 1 over 1 plus x squared, which is almost what they want. Right? This is the one they want. This is the one we've got. So there's really just an extra negative to deal with. Okay? So when I go to do my manipulating, I'm just going to add an extra negative sign now that I know what it's supposed to look like. So I'm going to go back up here. So negative 1 over 1 minus negative x really is negative 1, the series that represents 1 minus negative x. That's the actual series that represents this, which I know if I take the derivative, I'm going to end up with what they're asking for. And now I just need to come up with the series that makes that happen. So what do? Let's list out some terms and take the derivative. If I list out terms, I'm using this series to list out some terms. I've got n is 0, so that's just 1, but it's negative 1. Plus, because it's going to alternate, right? This is really negative 1 to the n, right? So it is going to alternate. It's just that it started negative this time. So n is 1. Now I've got a positive x to the 1 minus x to the 2 plus x to the 3 minus x to the 4, and you can kind of see what's happening. So it's not that much different than what we did before. Replacing the x with negative x, so now it does alternate, but it not just alternates, it actually starts on the negative. Okay, now this I can differentiate, right? If this is the actual function, I shouldn't use f for all of them, but you can kind of see what I'm doing here. I've got this function represented by this series, so this function is represented by this series here using the terms, and if I want the derivative, I'm going to just go term by term and take the derivative. Alright, that's 0, that's 1, minus 2x plus 3x squared minus 4x cubed, etc. And now this derivative should match the derivative of this, which is that. Okay, so I'm going to rewrite it as a series now. My f prime, again, let me just call this g so you don't get mixed up. My f prime, which is based off of this, is starting positive, so that's negative 1 to the n. Right, n is 0, so it starts positive, and my terms, it goes 1, 2, 3, 4. So when n is 0, my first term is 1, so that's 1 more than my n value. Oops, that's 1 more than my n value. If n is 0, I get 1. If n is 1, I get 2. If n is 2, I get 3. What about x's? X to the 0, x to the 1, x to the 2. Okay, so that's just x to the n. So my derivative of this function, which I'm using to sort of, you know, as a manipulation of the one I know, looks like this. And because that's the derivative of this, which matches that, well, then my g of x is really 1 over 1 plus x squared, which is my series, negative 1 to the n, n plus 1, x to the n. And that's basically, what they want you to do, is come up with some manipulation of the known geometric series to represent the series they want using either differentiation or integration, and the key is you can go term by term and still get something equivalent to what your original function was. Okay, hopefully that helps. Just do what you can, and if you have any more questions, just let me know. Alright, I'll talk to you later. Bye.